Darkwave. Break it down. Darkwave. Break it down. Darkwave. Break it down. Darkwave.
The other one.
Break it down.
Hello, 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 everybody! Are we gonna play that racing game today? A game again? You mean marbles? You wanna play marbles there? Actually, I do have a Discord server. Oh yeah, that's an invalid link, right? I have to change that. I always forget to change that stilly link. All right, let me see if I have a better link. Sorry, my bad. There's my link there. Gotta remember to do that for every stream I come out with. I should probably do that now. Let's at least put this over here. Boop. Boop, boop, boop. Make bot here. Anna Ammo, how are you? I hope you're doing really well. Yeah, I have to copy pasta. You just joined my Discord? Thanks, bro. Yeah, I just have to do that, yeah. Hey God, I'm doing it the manual way for right now because I'm old and I'm boring like that. There, I just manually did it, but now I'll do it that way. So, edit com, Discord, And then I can just say exactly what you said there. My Discord channel is here. And then I just, oh, it'd be helpful if I copy paste that thing. So much manualness. Yeah. There we go. There we go. Got it. Thanks, Aiken. Maybe it was a miscommunication, Yusuf. Maybe that's what happened. Maybe it was a miscommunication, and that's what happened. I've never played Codenames, no? Should I have? Yeah, class at the top of the hour here in about 5 minutes. This is true. Gotta get geared up and ready to go. It's time to do some statistics. Oh, reminds me, time that I have to take my medicine. Can't forget about meds in the morning. Alright. Gotta do my meds, brah. No meds is no bueno. Whoop. I got no specs yet for you, Aiken. Buenos dias, Athena. I'll get around to that eventually, Aiken. I might be upgrading my system rather soon, so we'll see. We'll see how that goes. How is everybody doing here today? Happy Monday, Megan. Happy Monday. I hope you're doing really well. Happy Monday. We're back. We are back. We are B-A-C-K, back. Yes. I'm sure everybody is just as pumped as I am to get back to work. Get back to stats. Get back to having a little bit of fun. Full fat Milky. It is Milky. Back to the poggers. There you go. I like that. Never heard of somebody had a happy Monday? Well, Aiken, welcome to this stream. This is where Mondays actually are a glorious thing. We may not like taking classes, but we gotta make it as fun as possible. That's the whole point. We gotta enjoy ourselves. Cheska, hello. How are you doing today? I hope you're doing really well today. I hope your weekend was good as well. Look at this. We got ourselves bueno stuff going on. You gonna lurk? All right, Milky, you do what you like. Again, if you got questions, though, feel free to ask, okay? You're just as much as part of this class as anybody else, all right? You doing great? Oh, wonderful. I'm doing wonderful this morning. It is a nice day out. Well, I mean, as cold as it's gonna get, but still, it's a nice day out. And yeah, things were good this weekend. Got some stuff accomplished. Watched the Super Bowl. I kind of went to sleep at the end because I pretty much knew the final result. I'm like, yep, Tom Brady wins again. There it is. Cool Dad Club, how are you doing? Good morning to you. Good morning. How are you doing, my friend? I hope you're doing really well. I hope your weekend was good. Hope you had a lot of fun this weekend. Whew, got ourselves very good. Didn't watch the Super Bowl? I could understand that. If you're doing If you're doing family stuff together, totally understandable. You definitely get a pass. Definitely get a pass. I'm sure that your kids, are doing other things. That's cool, man. I got no problem with that. No problem at all. Ah, I see. I see how it is. You hate that Brady won another one? He's truly the GOAT. You've got that right. Brady is the GOAT. Brady is a man that you can never bet against. He will find a way to win. He is relentless. He is consistent, and he will destroy you once he gets it. Okay. Yeah. Yusuf was talking about code names, so I hadn't heard of code names until now. So yeah, looks like you guys know. So the spy master has to give a clue, and you have to guess what the word is. Oh, okay. So it's just a word guessing game with just like okay, that's cool. That's cool. It's a pretty nice simple game. I like that. That's got to be pretty fun. All right, it is 11:01. We got to get started here. Let's get going, ladies and gentlemen. All right, let's do this. Intro time. Okay, let's get started today. Welcome back. Welcome back to Monday. All right, hopefully you have a nice weekend. All right. So today, do I ever stream games? I can. I can stream games. That is something that could possibly be something I do from time to time. Mostly we're going to stream classes, of course, because that's the number one priority, of course. So, but games is something that I can do on my. Yeah. Um, let me time you out for a while. All right, good stuff. Thanks. Yeah, that was inappropriate. Anyway, um, okay. So I hope all of you had a wonderful weekend here today. We got a lot on the docket here to do today, in relation to what we did last week. So some of the stuff we'll talk about here from last week, and then we're gonna get right into the new stuff here this week. All right. So if you have your calculator there with you, we're gonna go ahead and use that here today. So make sure you have that out with you as we're gonna go ahead and put it together. All right. So let's go ahead and take a look here at the handout here from last time, and I'm going to bring up the big screen here. There. All right. So we did end off here last time at the last question here. So if you recall last time, we ended off at the 68, 95, 99.7 rule. Okay. So we did talk about that. We talked about the normal distribution, how to answer questions using the normal distribution from a basic standpoint. All right, we did look at that there very carefully. All right, today I'm going to answer the last question from the last handout. So really quick, it is the last question here that we just didn't get a time to get to. So we're just going to go ahead and talk about that. All right, so that's talking about number 11 here, which is what is Chebyshev's inequality? Okay, so we looked at the normal distribution here last time. Now we want to talk about a general distribution. So a normal distribution is a very special and unique distribution because that's the symmetric kind of bell-shaped curve distribution here. Um, so uh, with the Chebyshev's inequality, with any type of distribution here, for any data set or distribution, so again, this is for a generic distribution, at least 1 minus 1 over k squared times 100 of observations lie within k standard deviations of the mean, where k is any number greater than 1. So, for example here, if, let's say, for example here, we would have, let's say, k was equal to 2. So within 2 standard deviations of the mean. So if we talk about that, that's going to be 1 minus That's going to be 1, that here, 1 minus 1 over 2 squared, for example. Now, if we take 2 squared here as a quick example, that's going to be 1 minus 1/4. All right. So 1 minus 1/4, and if we multiply that by 100 again, it's a decimal, which will represent a percentage. That's going to equal, again, 0.75, or again, 75%. So in a generic distribution, whether it's skewed right or skewed left, okay, those are the other two that we kind of talked about there. In a generic type of distribution, what would you kind of expect to have happen? Well, you can kind of expect to have happen that 75% of data items within the data set would be within 2 standard deviations of the mean. Now, does that apply to every single distribution? No. But again, we want to get a ballpark estimate about what we should be right around, okay, at the end of the day. And that's where we kind of get this value from. All right, so it's a little bit different than the normal distribution here, which we talked about last time, which was the, a very specialized case. Okay. Okay. So, let's go ahead again, as I said here, for generic distributions that are not the normal distribution. All right. Okay. Let's move on here. Let's move on to the next part here, which is what we do need to get into here today. Okay. So, all right. Okay. So a lot to do here in this particular section. So let's go ahead and go over it. Now, some of this stuff here you don't need to memorize. I wrote this down here just for the sake of basically going over a few things. So don't have to necessarily write out all of this stuff here necessarily, but I do want to point out some very specific things here, so that way you guys know what we're doing. So let's talk about number 1, which is going to be talking about section 3.3, which is talking about grouped data. So how do we approximate the mean of group data? And then question number 2 here is, how do we find the standard deviation of group data? So we're going to do an example here of using group data here, but I do want to point out a couple of things. First and foremost here, how do we find the mean? Well, the mean here is going to be the sum of the class midpoint times the frequency of the class divided by the sum of the frequencies. And this is just with words. Again, in notation here with letters, this is what it reflects here as well. So xi is the midpoint of the class, and fi is the frequency of that class. More importantly here, though, I just give yourself a reminder here. Remember that the population mean here specifically is the letter mu. So we did talk about this last time here. Letter mu is the population mean in terms of its notation. We also talk about x bar here, which is the sample mean. So note that the book uses these quite often here. One's going to represent the population mean. X bar here represents the sample mean. Again, pretty much the same formula here, just different notations for each. Finally, it's the class midpoint here. We take the lower class limit of class 2, and lower class limit of class 1, and we divide that by 2. Okay, and before we do anything with the calculator, we will need to go ahead and find these midpoints. Now, you're probably saying, whoa, whoa, whoa. Lots of stuff thrown in my face. I said, fair enough. Absolutely true. So let's do an example here right away, and let's see how this will work out. Okay? So I'm not going to disagree with you. You're absolutely right. It is very there is a lot of information on this page. So let's make things a tad bit easier, okay? All right. So what I'm going to do here for our example for numbers 1 and 2. Yeah, no problem, my friend. Got to do examples, otherwise it makes no sense just writing up random words and random letters. Okay, let's do the same type of example that we talked about way back when. Meaning to say, let's say we had our set of test scores here. Hey, Sam, how you doing? You're here to be confused? Very good. Well, welcome to statistics, Sam. You ever want to learn how things are decided in business? Statistics is the way to be. I don't think you'll be too confused about this, though, Sam. Let's take a set of test scores here, and let's set their frequencies together. All right, so let's say we have some scores here. Now, let's say, for example, here, we're just given a range of scores. So let's say scores in the 50s, scores in the 60s, scores in the 70s, scores in the 80s, and scores in the 90s. Okay, and let's say I gave you a frequency list. Okay, so I'm just going to make up some frequencies here. Again, how many scores appear in each category or class. So let's say there were 5 scores in the 50s, 7 scores in the 60s, 10 scores in the 70s, let's say 17 scores in the 80s, and 9 scores in the 90s. Okay, so let's say this is our frequency distribution. Now, one of the things I want you to take a look at here in this particular case is that the difference between the first example we did is I gave you a data set full of actual test scores. I said, okay, this person got a 64, this person got a 73, this person got a 92. Okay, we knew exactly what those test scores are. However, in this case, this is more generic because of the fact that yes, I have 7 scores in the 60s, but I have no idea what exactly those 7 scores are. I have 5 scores in the 50s, but I don't know what 5 scores in the 50s that they are. They could all be 50 for all I know. Or they could be 51, 52, 53, 54, 55. Okay, I don't know. Okay, so I need to, again, for group data here, I need to kind of be a little bit more generic about how I'm going to actually find that as opposed to if I had specific data items. So that's where this midpoint part comes into play. If we talk about the midpoint here, well, then we could just, again, we're just going to kind of half-heart do this effort here and basically say, okay, well, let's cut our losses somewhere in the middle and let's take the midpoint of each class since we're given something more generic. So exactly how do we find the midpoint here? Because we will need that here for if we're going to put this in the calculator to do so. Obviously, we want to expedite this process, but we can't do that without the midpoint in each class. Now, as you can see here, how to find the class midpoint here, take the lower class limit of class 2 plus the lower class limit of class 1 and divide it by 2. So all we have to do here is remember that class 1, class 2 are basically 2 consecutive categories. So here's class 2 and here's class 1. Okay, so all we have to do for our midpoint here, again, 2 consecutive categories, so all we have to do is do 60 plus 50, and we just have to divide that by 2. And so that's going to be, in this case here, 55. Now, probably can see where this is going. This is not overtly too hard to kind of figure out, but it has to be just two consecutive guys at the end of the day. So we got here we got 70 plus 60, and we divide this by 2, and so this is 130. And so 130 divided by 2, we get 65. And I'm pretty sure you can probably guess the rest here, which should be pretty obvious by now. But again, just to show off the work here about how I can find these midpoints for each category. So here we get 75. And we get 90 plus 80 divided by 2, which is 85. And then finally, the last one here, I know it's going to be 95 here, but what you're going to do here specifically is you're going to imagine if there was a next category or next class, that would be technically like 100 to 109. So imagine, if you will, that the next category was there. So that's why you're going to still take 100 here, and you divide that by 2. So you still can justify the 95 here, okay? But even though it doesn't exist, you just think about that if it was there, then that's what you essentially do. Do I listen to Kanye West music? No. I listen to Eurobeat music all the time. Well, that and a lot of other things. But I've barely listened to Kanye's music, so okay. All right. So we have our midpoints here. We have the frequencies here. All right. Now, let's go to the calculator. All right, so now it's going to be calculator time for us to use our next guy here. So, go to the calculator. Wait for it to load up here. There we go. Bosh. Okay. All right. So let's follow suit here. Let's follow through here about how we can find the. We're going to go ahead and find the mean here, and we're also going to find the standard deviation here using the calculator and the setup that we have over here to our right. Okay. First, let's hit the stat key here on the calculator. All right. And we're going to go over here to edit. Okay, so we're going to go to edit right here, that very first choice. Ba-bam. All right, now you may have values in here already. Let's go ahead and clear those out. Again, I want to do this with you. So if you have something, highlight the list here, hit the clear key, hit the enter key. So I'm just going to hit the clear key and the enter key to clear out those lists. All right, so let's go through this together here so that way we can all follow along and we can all see exactly what's going down. All right, so here in list number 1, we're going to put the midpoints that we found here from before. So list 1 here is going to represent the midpoints. But 55, 65, 75, 85, and 95. How do we clear? Okay, so Feiner, we clear by highlighting the list. So hit the up arrow, so make sure that the list is highlighted. Hit the clear key, and hit the enter key. Okay? That's how we can clear the list there. So it makes it significantly easier. All right, cool. Okay, once you have the midpoints in list number 1, in list number 2, we're going to go ahead and put the frequencies into that list. So list 2 here, we're actually going to use here, we're going to put the frequencies here that I just randomly made up. So 5, 7, 10, 17, and 9. Okay, so we're going to get that going right there. Perfect. Okay, let me know. Go ahead and type in yes in the chat once you have that entered into your calculator here. When is all the homework due by? Again, whenever the first test is going to be. No worries, my friend. Like it may. I'll have to switch those due dates, but I'm not sure yet because it just depends on the pace. So I kind of go with what you guys do. So whenever that happens, then I'll make up the test after the pace. So that way, it's again, it's not on a set date. It's fair for everyone. But once the material is done. Okay. So, all right. So everybody has that there. Again, I hope everybody has their numbers put into their calculator. If you do, great. Otherwise, does anybody want me to wait for just a second? Or is everybody good? Is the test next week? That's a possibility, yeah. Like I said, I'll make a, depends what happens this week, and then I'll let you know. Gee, all right. Get banned. All right. No problem. Okay. So let's move on here. So we want to quit out of this menu to the main menu. So it's second in mode to quit to the main screen. Okay, so we're going to quit to the main screen here. All right, now, this time we want to hit stat again. So let's hit stat, and let's go to calc. All right, let's go to calc. We're going to go back to 1var stats. Now, we used this before last week, all right, in order to go ahead and find the standard deviation and whatnot. We're going to go ahead and use this again. However, there will be a subtle change, all right? So let's take a good look here. The difference is going to be what we're going to put into our calculator. First of all, you see at the very top, you should have list here. It should be L1. If you don't have L1 on the screen, go ahead and hit the second key and hit 1. And that'll bring up list number 1 as it's right there. Steven Stokes, how you doing, my friend? Hope you're doing well. The frequency list now, we actually do have a frequency list. So maybe it was blank before, like it looks like this. It was blank before, but now we actually want to put in a frequency list in here. So we're going to hit second and 2 in order to put in the frequency list in that spot. Now, if you have the old school calculator for the frequency list, so if you unlist there BMZ, you want to hit second and 1 there to get list number 1. So second and 1 to get L1 to show up. If you go into a frequency list, it's second and the number 2, and then L2 should show up there underneath frequency list. Now, if you have the old school calculator, like I know some people do here, that's fine. That's exactly what I'm going to go over here, Athena. I'm going to acknowledge this right now. If you have the old school calculator and you hit 1var stats, and of course all you see on the screen there is just 1var stats. So what you'll need to do here is, this is what you see on your screen. You're going to go ahead and hit second and 1 to get L1 to show up. Then I want you to go ahead and hit the comma key here. So hit the comma key here. The comma key is right above the 7 key, right below the sign key, comma L2. So actually that should look a little nicer, sorry. So L1, comma L2. And then go ahead and hit enter if you have the old school style calculator. If you have the new school style calculator, then this is what you see on screen. Go ahead and get down to calculate, and then this is what you'll see. But let me go ahead and hit second and enter here for just a second. For the old school calculator here, what you see up here on the screen right now is what you should have entered, and then you could go ahead and enter and get back to the screen, that I was at just a moment ago. Okay, so for the old school, this is what it'll look like. The calculator, if you have the new style software, will automatically do this for you. I want everybody to type yes in the chat once they have this have these results on their screen. I want to be sure that everybody is taken care of here. All right. Again, if anybody's stuck here, ask questions right away. Okay. All right. Good. You deleted L2 on accident. Can you get it back somehow? Hey, Yellow Mayo. Yeah, so the way you kind of have to do that is you're going to have to hard reset the calculator there. So if you do that, Athena, if you're talking about L2 the list, are you talking L2 the list like here, like in the edit menu, Athena? Oh, okay. Yeah. So there's only one way to really get it back consistently. So it'll reset the calculator here. No, you didn't, Yellow. All right, so you hit the second key and the plus key here. If you go to 7, number 7 down here, Athena, hit reset. And then you go to all RAM, just hit enter on all RAM. It'll hard reset the calculator. And then you'll see L2 again in your list. So be sure Be sure, Athena, not to hit the delete key. That's really bad. You don't want to do that. All right. You'll have to enter in all the numbers again, but that's how you can get L2 back. I'm just going to point that out there. All right, cool. Okay, so let's take a good look here at our answers. Our answers here are going to be, first and foremost here, we see our answer of our mean here. Our mean here is going to be 78.75. All right, so let's go ahead and put this down here. 78.75 is what we get here. We also have our respective standard deviations here. So again, Sx, as we talked about here last time, was our sample standard deviation, which is 12.4840. So again, and then we also have our population standard deviation. If they do ask for that, then again, 4 decimal places as usual. So 12.3533. Okay. So again, not intended to be super hard, but again, that down a little bit. Not intended to be super hard, but again, now you know how to use the calculator for group data here to get both the group data mean and the standard deviation here as well. So you should be good to go on that front. Okay. Are there any questions about that? Yes, Athena. You type the midpoint here. What was the look on the bottom right hand corner of the screen there, Megan. It's 12. It's this right here, the 12.3533. That's going to be your population standard deviation. So that's the difference there. Sx is the sample standard deviation, and then I obviously can't put that in the chat because Greek letters are kind of hard for me. But OX was equal to population standard deviation. There you go. Yeah, so there is a distinct difference between those two, and they do have their own unique calculations. So that's why we have to go ahead and point that out. Any other questions? Any other questions from anybody so far? Nope. Okay. No. Okay. All right. Okay. Let's move on here with the handout. All right. So got a lot of stuff done there with that first one. So just exactly what I was hoping for, to be honest. All right. Okay. Now, we're going to talk about the next part here, which is talking about number 3. Number 3 says is how do we find the z-score here? How do we find the z-score? So, one of the things we'll talk about here is this concept of z-score. This is going to be a concept that's going to come up quite a bit when it comes to statistics because we're going to be able to relate z-score here and actually make some conclusions off of z-scores, based on what it represents. Well, first of all, let's talk about the definition of z-score. Z-score here is the number of standard deviations a data item is away from the mean. So when we talked about the normal distribution last time, we talked about, like if we had a mean of 10 and a standard deviation of 2, the example we did last week, we said, okay, well, if we looked at 12, 12 is plus 1 standard deviations above the mean. We said 8. 8 is 1 standard deviation below the mean, or minus 1. All right? Those can be related to z-scores, okay? So those +1 and -1 things are essentially z-scores at the end of the day. Again, 1 would be 1 standard deviation above the mean, -1 would be -1 standard deviation, again, minus that standard deviation below the mean. Okay, now we do have a little formula that goes with this. And this formula is that the z-score here is equal to the data item minus the mean, all divided by the standard deviation. Now, of course, we will be given some information here regarding the mean and the standard deviation, so we're going to need to know that ahead of time before we actually figure out what the z-score is in any given case. As I mentioned here before, it is okay to get a negative z-score. So we could have positive values for a z-score. We could have negative values of a z-score. Again, positive means above the mean, negative means below the mean. All right, just as simple as that. Then we take a look here at the notation. And the notation is something you will see kind of mixed around a little bit. So these are the two main notations here that we're going to see. If there is other notations that pop up, certainly I'm going to let you know. But these are the two major notations where you may see Z, all right, or you may see Z sub the whatever data item that we're testing over. So like if we're testing over a data item of like 58, then I'm going to have Z sub 58. Is that Z comma? No, this is just to separate that out, Feiner. So it's like two different notations here, Feiner. So it'll be like Z and Z data item. So two different notations there, meaning the same thing. It's just two different notations, Feiner. So just don't get confused about that. I just want you to know it's like, oh, okay, this is two different notations at the end of the day. They could be listed as that or that, whichever one the book kind of shows. Now, one of the things that we do have to talk about here is we do have to talk about this note right here. This note here is incredibly important. That is that every data item has a unique z-score, okay? Every data item has a unique z-score. The only way they match is if they're the same exact data item. So, and that's because of the actual formula that we have here. We actually literally take the data item, subtract it by the mean, and divide by the standard deviation. So no matter what, we're going to get something slightly different for every different data item. So again, you're not going to always get the same answer unless you have the same numbers in place. Okay, well, let's do an example here of a z-score, and let's see how it works. It's really not as bad as it may seem. It takes very little to get used to, in all honesty. So let's put an example here. Every time a z-score thinking, well, Wade, I'm going to be honest with you. I'm not going to take 20 streams / episodes to finally get around to killing off a section, okay? I promise you that. All right? But I can do epic intros. I could do epic intros here, you know. I could be like, next on Dragon Ball Z, Krillin dies again for the 10th time. And Goku has to bail him out again for a 10th time. Meanwhile, Vegeta broods in his corner, trying to surpass Goku, but never quite does. Also, Goku's a terrible father. You know, something akin to that. Oh my gosh. Vegeta's the kind of character who never grew out of his emo phase. Never. That's Vegeta. That's Vegeta for you. I always have to beat Kakarot. Always. Like, really? Yeah, all the time? Like, bro. Like the Prince of Saiyans, it's okay. You don't have to beat Goku all the time. Just be yourself. All right, let's take let's take a good look here at this example. Oh my gosh! All right, let's take a look at the mean here. So the mean here is going to be, let's take the mean here to be self-love is important, Vegeta. My favorite scene. Where is that scene? From Dragon Ball Super. See here. I want to see if I can see if I here it is. Okay. Okay. All right, everybody. We're going to watch a slight video here. If you want to see how ridiculous for Dragon Ball is, it's just it compounds down to this one scene. Okay. All it compounds to is just one scene in Dragon Ball Super. So we'll just watch it really carefully here.
Everyone.
Whis! Listen, you can't just come barging in like this. Bulma's in a very delicate state. What is it? Whis, is this really my baby? There's little one.
Well,
And according to Dragon Ball logic, that is how babies are born. That's how babies are born, everybody. Dragon Ball logic at its finest. Oh my gosh. Just absolutely. If only, yeah, look. A woman doesn't need to go into labor. You don't need to go to the hospital. Okay? You don't need to go anywhere. You just sit down in a lazy chair, and you could just have somebody hover a stick over you, and just magically it pops out. Yes, exactly. Cool, Dad. You gotta show your wife that. That's exactly how they were born. Just hover a stick. Say, look, she had it so. That scene in subbed was that scene in subbed was hilarious. That's true. It's true. It had to be done. The memes are real. Oh my goodness. Oh my goodness. It's the most ludicrous thing I've ever seen. I'm like, only in Dragon Ball can you technically get away with that. Only in Dragon Ball could it be conceivable. Oh my gosh. All right. All right, we got to move on here. I'm going to die laughing today. Holy smokes. Cool Dad's got a video to show his wife later. All right. Let's take a good look here at let's take a look here at an example. So the z-score here, we have a mean of 25 and the standard deviation of 3. Now let's find a z-score here of a particular data item. Let's find a z-score here of, let's call it 27. Let's call it a z-score here of 27. All right, so all we're going to do here is we're just going to follow the formula that we have over here to the left. And we're going to put 27 in here. And put that in parentheses because, of course, they're just subbing that in for data item. And the mean and standard deviation are going to remain the same because those are given to us here in this particular case. And in this instance, we're going to have 2. Oh, I'm so sorry. I've ruined your day, Athena. I'm so sorry. as a as a math teacher, I'm supposed to ruin everyone's days. I guess I did my job. So here we're going to get 0.67. Okay, so we're going to get 0.67 here. If we round to 2 decimal places here. I didn't round to 4 decimal places for this. Just because I'll show you here in just a little bit about why I didn't round to 4 decimal places. But 0.67 is what that would round to. And that one's pretty easy because it's 2/3. Okay. Let's try another one here. What about z of call it z of, call it 19. Let's 19? Not 19. 17. 17's fine. Let's go z of 17. What would be the z-score here for 17? Be the z-score here of 17. Let's take the decimal equivalent here. So I'll have you guys kind of fill in the gaps here. So z-score here of 17. Minus 2.67. Okay, good. That is correct. So we have 17 minus 25 divided by 3. Spot on. Very good. Get minus 8 over 3. Okay. So again, what do these mean? If I looked at 17, right, I would say that 17 is minus 2.67 standard deviations away from the mean. So now we can actually find specific standard deviations as opposed to like just 1, 2, and 3, or minus 1, minus 2, minus 3. Okay. So z of 27 here, again, would represent 0.67 standard deviations away from the mean above it. So there you go. Simple enough. Good job, everybody. Nice. Okay. Questions about z-scores here? Nope. All right. Hopefully that's pretty easy there. All right. All right. So let's go ahead and take a look here at why z-scores are very important. Now, one of the things that we're going to relate z-scores to is we're going to relate it to actually understanding where a z-score ranks in a data set, i.e. the percentile. All right, so what I'm going to do next here is I'm going to put up let's be a little bit more interactive. I think interactivity is fine. All right, where is that? There it is. Let's put up a poll here. So let's put the I'm going to put up a poll up here, a really quick one. So, did you take the ACT, SAT, or both? I know some of you got that there. Hey, Breadstick, thanks for the thanks for the bit. Appreciate it. And yeah, thanks very much. Cool, Milky. I appreciate you. Oh, no Pepe laughs. Go ahead and you can vote up top there. If you did the ACT, SAT, or you did both. I know everybody's got a different thing that they did in school. So some people did both. Well, a lot of people did both. More than the first time I asked. No, remember, that's fair. It's fine. Okay, with the SAT, go ahead and put that vote up top. All right, just about to end this poll here. A levels, that's fair. All right, so it looks like a lot of you did the SAT. I see 8 people did the SAT, 3 people did both, and 1 person just did the ACT. That's just fine, which is fine. So, as you know here, if you did the SAT, of course, that's now out of 2,400, and the ACT is still out of 36. I can let me go ahead and I'm going to put a prediction here. This is either a yes or no prediction. So you can use your channel points to get a prediction here. What was, I took the ACT. What was my second ACT score? So that's what you're going to bet on here. The first outcome is 25 or lower, or above 25 would be the second one. So I'll put a prediction up there. I don't know, what you guys, the SAT was out of 1,600. They switched it to 2,400. So if you put some channel points there, what do you guys think? It's out of 36, is like ACT stuff. You can put the prediction up there. You can bet some channel points at 25 or lower, or above 25. What do you guys think? Ooh, wow, lots of channel points put up. Ooh, bet 3K on that. What? Who put 3K? Wow. You went all in and above 25? Man, you're a bold man, Milky. All right, what was my second ACT score? 7K! Holy smokes! Wow. I don't even know what that means. That's fair. Holy cow, so many people. Milky went up to 2,900 channel points. That's amazing. All right, so let me choose the outcome here. The outcome here is my ACT score was 25 or lower. So I actually scored an exact 25 on my second ACT. There you go. Thumbs up indeed. So if you guessed 25 or lower, that's perfectly fine. I did I got a 22 my first time on my Hey, hey, look, it's a fair thing. It's channel points. You'll get them back. I guarantee you. ACT's out of 36. 36 is a perfect score. Let's gain 7,000 points. Very nice, Tristan. Very nice. All right. So I got a 22 the first time. And then I took it a second time, and I got a 25 the second time. So I've always been a B student there. So being a B student is just fine for me. I've never got straight A's in my life, so that's not a big deal. So I was pretty happy with the 25. And then I got into U of I, and then then it was a disaster after that. That freshman year. That freshman year. Yeah. That freshman year at U of I. Sigh. Oof. That was a big oof. I'm not gonna lie. All right. In any case, what's the point of me asking this question here? Well, the point of me asking this question is talking about specifically the percentile. So when you get your score that you got on your test, whether it be the ACT, SAT, or whatever, whether the SATs, if you did it from a long time back, would be out of 1600. If you did the ACTs, would be out of 36. Okay, they basically, what they did was, is that again they compared you to how you did with the rest of the people who took that same test. So if you just scored really well in say the math section and you say, "Oh, okay, I did really well in the math section. All right." So you scored a 30 and they say, "Okay, well a 30 ranks in the 93rd percentile, which means that you did better than 93% of the people who took that same exact test in that subject." Okay, so obviously the higher the percentile, the higher that you are there at the end of the day. Yeah, that's fair, Milky. That's fair. It does depend on cohort. That's actually true for Milky, that's actually true for nursing. Nursing, that's very true. The grade boundaries definitely shift in nursing. So nursing is very strict. Very, very strict about their GPAs and grading. So A minuses actually count and stuff. So was that today's PogChamp? Okay, got it. Okay. So, uh, what we have here again is what we want to look at from a statistical point of view. We want to look at statistics and data items in a data set the same exact way. So what it means to be a percentile says the data item is K% better than all other data items in the data set. Okay, so essentially, if that data item is very high in the data set, then of course that would be in the very high percentile, the 93rd percentile, for example. And again, all data items would be all data items, 93% of data items would be below that data item in the data set. Or you can look at it vice versa, as I just mentioned, that data item is higher than 93% of data items in the data set. Whichever way you want to look at it, they're both valid. Okay, so what are we going to use these percentiles for? Okay, that's the more important point here. What's the point of these percentiles? All right, so what we're going to use these percentiles for is we're going to start constructing a box plot. What we've talked about here in these first 3 chapters is a way to kind of put together data, organize data in such a way where we can interpret and use it in an easy to use manner and make some conclusions based off of it. Which type of grade of math is this? This is college statistics. That's what this. Um, so we're going to construct a box plot here. We're going to look at a different way to put together a data set there in a much more compact way where we can see some of the more key details that we may want to clue in on, and actually look at a physical representation of the maybe how wide the dispersion is, okay, or again, take a look at how compact that the data set is. Just depends on what items that we're given in here. So we're going to talk about box plots here. Now for box plots in specifically for box plots here, we actually are going to be dealing with specific data items, unlike what we did in section 3.3. So I'm going to come up with an example here, and we're going to, of course, relate that to what we see up here for question 5. So let me make up an example here. And I may not get through this whole example today, but nevertheless, we'll need one. So in this case here, I'm going to make up a stem and leaf plot. All right, so let's go ahead and make up another stem and leaf plot here. So 4, 1, and 2 and 8 and 5 and okay. So let's say this is our data set right here. Okay, it's a rather large data set for this one, but it will highlight some important things. So we're going to go ahead and put it together here. Okay, now for us to go ahead and put together this data set, what we want to do is we want to let's go over each one here. I'm going to kind of skip ahead here because we're going to kind of come back to each one here specifically as part of the steps into constructing a box plot. So you'll see me kind of go back and forth here a little bit. Okay, so don't be surprised about what's happening here in terms of how I'm using the handout here from before. So let's take a good look here on how do we construct a box plot. Okay, so I'm going to go in steps here. All right. And so it says step 1, order the data set and find the median. Now, for this particular example, I went ahead and ordered the data set. So it's already in numerical order, so we're fine. We just need to go ahead and find the median. Just like we talked about last week, how do we find the median? Well, we need to find the position of the median, and then of course we need to find the median outright. So first of all, let's talk about step 1 here as part of our box plot. It all has to start from the median. And we'll let you know here, the median here is incredibly important. Okay, you will need to find the median here first and foremost before anything else. Okay, so let's first find the position of the median. Okay, so we're going to have, again, can anybody tell me here, what was the position of the median? So what is the position of the median? What was that formula? This one you can't actually type out. What is the position of the median? What's the formula for that? N plus 1 divided by 2. Okay, that's correct, Cheska. Very good. All right, it is indeed n plus 1 divided by 2. Now, what's n in this case? Totally agree with that, Cheska. That's correct. What is n in this instance? All right, BMZ, that's right. Now I want to know what n is. Be careful about that there for capital N. Remember, capital N here. You know what? Don't worry about it for right now. That's fine. That's fine. You know what? I don't want to make things more confusing than they need to be. What's our sample size here? How many numbers we got? How many numbers we got here in this instance? 17. That's right. Okay, good. So n here is 17. I agree with that. Yes, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we got 17 numbers. That's okay. I'm making sure everybody's on the same page, which is why I kind of slowed down there. We got 17 plus 1 divided by 2. So 17 plus 1 is 18 divided by 2 here. So we want the 9th position. The 9th position is where we're going to specifically find this number here. So go ahead and take a look here. A bit bigger. Well, let's look at the 9th position. Remember, the median is not 9. This is just where we're going to find the median specifically. So let's count up to the 8th number there. Can I move my... Oh, yeah. Sorry, Athena. Hopefully I made it bigger, so... Let me remove my face from the... Go with the no face here. There we go. So we have 9. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. The median here is indeed 24. Look, I understand, Athena. Just say, hey, look, I understand, Athena. Just say I hate your ugly face, and then I'll just change it to no face. That's not a problem. I can do that. So, like your face, it smells. I'm like, okay, that's fair. You know what? I'll move this over to the right hand side here. I paid for this course, but I don't want to see your face. Like, okay, that's cool. Okay, whenever I think about anybody, I always think about this. Okay, so it's always the Drake meme. All right, you're just like, nah, bruh, nah, and then be like, okay, I get it. I get what you're coming from. Be like, nah. It's like, okay, I just put up this meme every time. Every time you don't want to see my face. Like, I totally understand. Okay, totally get it. Totally get it. All right. Okay. So now we got now we have okay. So we found the median here, which is 24. Okay. Let's look at step number 2 here on screen. We're going to find Q1 and Q3. So we're going to find Q1 and Q3. Now I need to describe Q1 and Q3 here. And this Q1 and Q3 here, the box and whisker has been summoned. Almost, but not quite. Not quite. Got some work to do before we can summon the box and whiskers, my friend. Got some extra bits. So the first thing I want to do is describe what Q1 and Q3 represent, because I can't do the box and the whiskers without them. First of all, Q1 and Q3 is referencing percentiles. Specifically, that's what number 5 is about. Q1 is the 25th percentile, and Q3 is the 75th percentile. Okay, but I need to be a little bit more specific than that even. How do we find Q1 and Q3 here? Now, naturally, you could use the calculator, but there is also a separate meaning to Q1 here that if you have a small enough data set, you can find it without the calculator as well, if you just write it out. So the way I kind of approach this is like this. If I want to find Q1, Q1 is the median of the data set that is to the left of the median. All right? So it is the median of the data set that is to the left of the median. So the median that we had just found here, which is 24, okay, so I'm going to point this out here. Be like, well, you know, that looks really confusing. What exactly do you mean by that? Okay, well, let me try and visualize this for you so it makes it a bit easier. So I'm going to circle in blue where the median is. The median is right here. That's where 24 lies. Okay, so we found that from the first step. Now, what do I mean by the median of the data set to the left? Well, all the numbers to the left of this 24 are all, I'm going to look at all 8 of those numbers there. So I'm going to circle that in red. Okay, so I'm going to circle this in red here. And these are all the numbers to the left of the median here. All I have to do for Q1 is to find the median of this data set here. Okay, so then I just said, yes, that is correct. Very good. Beyonce has come through again. Queen Bee knows what she's talking about. All right. So she set the standard here. Everything in a box to the left. In this case, we'll find the median of the box to the left. That's most important. All right. So all we have to do is find the position of this median here, and then find exactly what the median here in this case is going to be. So in this particular instance, the position of the median here, and I'm going to put this in red here, the position of the median. So basically, the median, the numbers before the first median. Correct. That's correct. That's correct, Toaster. So I'm going to just show this off here. The position of the median here, in this instance, is going to be 8 plus 1, because there are 8 numbers in that data set. So that's going to be 4.5. Okay, so that's going to be 4.5 here in this case. So I pick out 4.5. 1, 2, 3, 4, 5. So 4.5 is right where this arrow is. The 24 is not included? No. We do not include the 24. So you know what? Let me make that a little bit more clear for you, Athena. I'm going to put an arrow here, the blue arrow. The blue arrow here is going to represent the median of the data set. So I want everything to the left of that blue arrow, okay, as the left side of my data set. Everything to the right of that blue arrow, I'm going to have that as the right side of my data set. But at no time am I including that arrow, okay? So I hope that makes it crystal clear here about what we're including and what we're not including. And you'll do that for every single data set, okay? Okay, cool. All right, so all we have to do is find the mean here between these two. So the median here, oh, not in blue, I want red. So our Q1 here is going to be equal to 16 plus 19 divided by 2. And so that's going to be 17.5, 17.5. All right, so that's Q1 here. All right, Q1 is equal to that. All right, are there any questions about Q1? I'll move on here to Q3, but want to be sure that everybody is on the same page when it comes to this. Okay. All right. I just want to be sure everybody's cool. So, yeah. Okay. That's a very good question, Cool Dad. Very good question. So, let me go ahead and describe here. So to reduce that. So I'm just going to go through in order here, so that way I'll show you what each one of these quartiles mean. So the 25th percentile, the median of the data set that's to the left of the median. The 50th percentile is exactly what you think it is, Cool Dad. It is exactly the median. Okay, so the 50th percentile is the median itself. So Q2 is just exactly 24. Okay, so we don't need any special calculations for Q2. It's exactly what the median was that we found in the first step. It's the 50 percentile, so it's dead set in the middle. Okay. All right. So hopefully that clears that up there about what each of these represent so far. Anyway, we still have a couple more to go here. All right. Cool. All right. Now, to go along with that, the median has now been passed. So we go to the 75th percentile. Now the 75th percentile is going to be pretty much like the 25th percentile, like Q1. Again, though, this is the median of the data set. That is to the right of the median. Okay? The median of the data set that is to the right of the median there is going to be the 75th percentile. So we're now going to go a little bit further. We're now going to go, I'm going to circle this time here, and I'm going to expand on this. So I'm going to, let's see, let's put in purple. So everything to the right, okay, everything to the right of that blue arrow. So I'm going to circle all the numbers here to the right. This is all the numbers to the right of the median in the data set. And we're going to find the median here in this case. Now, it follows suit that the position of the median is going to be exactly the same, as still be in the 4.5 position. So, because we have still 8 numbers, we have 1, 2, 3, 4, 5, 6, 7, 8 numbers in here. So, let's count 4.5. We got 1, 2, 3, 4, 5. So the 4.5 position here would be right here, right between the two numbers of 37 and 41. So in this instance here, make this a bit bigger. Well, I can show this off here. Q3 will equal 37 plus 41 divided by 2. And so this is going to equal 39 at the end of the day. So we have 31, we have Q1, which is going to be 17.5, and we have Q3, which is 39. Let's go ahead and put both of those down. And we also have the median here at 24. Okay. All right. So we found all three of those values here. Again, the same way here. No problem. Pretty easy. Easy peasy lemon squeezy. All right. Any questions about any of that? Any of that so far? I'm gonna continue with this question here, but no. Okay. Now, let's look at the last one here, the 100th percentile. The 100th percentile is pretty easy as well. Just like the 50th percentile is the median, the 100th percentile here is going to be the highest value in the data set. Okay. So the highest value in the data set. I'm going to switch to my face cam here. Okay. So the highest value in the data set here is going to be the 100th percentile. So in this case here, the highest value here is, of course, 52. So we can see here 52 is the highest value in the data set. Now, normally we don't list Q4 because, again, it's pretty simple. Okay, you just have to see what the largest value is. By this point, if you've already found Q1 and Q3, you know that the data set's already in order. So finding the largest number there is just looking at the end of the list and then calling it good. So really isn't too hard to figure out exactly what we get from that. It's actually relatively straightforward. Okay. Will I have time for that? Oh, maybe I won't. I'm like running. Oh, I'm really out of time here. Okay. That actually take me more than 3 minutes to explain. Ah. Okay, so here's what I'm going to do here. We are out of time here for today. So what I'm going to do here is I'm actually going to save this. This is our classroom example. Ah, I know. It's so terrible. uh, on the desktop here. Okay. All right, so I'm going to save this as Boxplots Math 102. Hey, Danos, how you doing, my friend? Danos, hope you're doing well. What was that Q3 again? Yeah, let's go over that. That's fine. Let me put that up here. So Q3 is going to be 39. Again, we took the midpoint, we took the mean between 37 and 41. So I took 37 plus 41. I divided it by 2. And then I got 39 here as my final answer for Q3. Now, what we're going to be doing here next time, everybody, is we're going to put this together in a box plot. Unfortunately, I kind of ran out of time here. But I'm going to use the same exact example here. Yeah. So one of the things I'm going to do is I save this. I save this here. So that way we're going to come back to this example here for next class. We're going to use the same exact numbers here. And then we're going to continue making up our box plot from there. Now, I do want to actually say something here before we end off class for today. As was asked earlier by Jorge, was about regarding the test here. Now, after we're done with these couple of sections, we're gonna be doing a test here over chapters 1 through 3. Now, just to let you know here, that will not be until at least a week from when we finish. So if we finish next class on Wednesday, that means that the test will be due probably that following week, more than likely the end of that week, so probably on Sunday. So I'll give you like a week and a half to finish the test. So I still have yet to make it up, so I'll be making it up probably tomorrow or something. It shouldn't take me that long to do, but I will curate the questions very carefully, of course. And then we're going to talk in a little bit more detail about what I expect there for the test there. I'll also be putting up an announcement on D2L and sending you out emails regarding that as well. Will there be a study guide? The answer is yes, in a way, Athena. I'll be also posting a practice test, which will be basically the test, just you can practice with those similar type of questions so you can get more comfortable with not only the formatting, but of course with the types of questions you'll see on that actual exam. And you get unlimited tries on the practice exam, so that way you're prepped and ready to go when you actually put together the real exam. So um, again, yeah, of course, of course. That's one thing that I do want that I did say I would do, and that's something that I'm still intending to do. That hasn't changed whatsoever. As for the number of questions or again things of that nature, I don't know, what the number of questions are going to be offhand, but I'm going to attempt to make it shorter so it's not super overwhelming. Practice, yeah, everything is going to be on my math lab, Michelle. So so yeah, everything is going to be on my math lab. You'll be perfectly fine. The practice test and the test will be on my math lab, so you'll have a chance to work that on then. So that shouldn't be too much of a problem, in all honesty. Yeah, yeah. I'll be describing more on Wednesday, so I'll be answering more of your questions because then I can give you a more detailed rundown. As for time, yeah, don't worry about time, anybody. I'm gonna give you a ton of time. I mean, and I literally mean a ton of time. So, um, those of you who are worried about time for me, yeah, I wouldn't worry too much about time. So as people who've taken my class before can attest, I give a lot of time on tests. Excuse me. What homework should we keep up for Wednesday? That's a great question. I think Cheska up to that last section, up to section 3.5. You may not be able to do all of it because um, obviously we haven't done the completion of box plots, but you can do a little bit of it with the Q1 and stuff like that. So you do just a smidge of up to 3.5. You won't be able to do all of it because we haven't gone over all the questions just as of yet. Okay, but we will finish up here chapter 3 for next time. That I can promise you. All right. I hope I'm hoping here. Let's go ahead and take a look here. Let's put up this. That's fine. Let's go switch this. I hope everybody has yourself a very wonderful day. Okay. We were going to see you on Wednesday, okay? This same time, same place. You know where to find me. I'm not going anywhere for a couple days. All right. All right, everyone, take care of yourselves. I'll be back for my next stream in about 12 minutes. So 12 minutes will be next stream here for another 102 class. If you'd like to stick around for that, you're more than welcome to stick around. If not, I want to thank you all very much once again for coming on out. All right, love you guys. You guys are wonderful people. All right, have yourself a wonderful day. Stay safe, stay healthy, and most importantly, everybody, stay sane. Take care of yourselves, everybody. Have a good one. We'll see ya. See ya, Wade. Yeah, have a great one, my friend. You take care.
that you could save me from my isolation. It's way too complicated. Let's start this conversation. Let's start this conversation. We got no relation.
All right, let's do this. Hello, hello, those of you who come early. Hello, hello, hello. Hopefully everybody's doing really well here today. Happy Monday. Hello. Hey, Banana and Planet, how are you guys doing today? I hope you guys are doing well. Do you have a... How we doing today? Hope we're doing good. Yeah, 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 yeah. Alyssa, hello. How we doing? Planet, you're doing good. That's good. Great. I'm happy to hear that. Hopefully you had a wonderful weekend. Banana, Alyssa, I hope you guys had wonderful weekends as well. So far, so bueno. Oh, I'm doing good. It's been already an amazingly productive day. I think we're in a good spot right now, for sure. So we're definitely on the productive train, heading everywhere. All right. We're in a very, very good spot. It's going to be a nice, exciting day as always. First class was pretty crazy. Let's see how far you guys stretch out my crazy. Crazy is not a bad thing. I'm just gonna guarantee you that right now. Like, we all like being crazy every once in a while. Feels good, man. What you guys get up to this weekend? Or did you guys watch the Super Bowl? I don't know what you guys did, but if you watched the Super Bowl this weekend, there you go. That's where it's at. Where it's at this weekend, yeah. Art analysis and a test this weekend. Oh no. No Super Bowl? Sad face. So I hope you did well in the test there, Banana. Got a B, but could have done better. Alright, that's fair. I'm sure you could have done better. I don't disagree, but you know what? You did the best you could, Banana, and I'm happy with that. Excellent. Excellent stuff. Ooh, what am I drinking today? Today is just water. Today is just my 1 gallon of water. Today, that's all I got right now is my 1 gallon of water. I'm gonna get some new drinks though, that's for sure. So, new drinks are on the horizon, I can promise you that. So responsible. Gamers, so responsible. This isn't as fun to say outside of Discord. Hazelnut. I respect that. Gamers. There's nothing wrong with being a gamer. I've been playing I've actually been playing a game this weekend, so I've been accessing my inner weeb, okay, this weekend. All right, that was very important. Okay. Your face is falling back to your MMO. That's fair. That's fair. Game of Thrones and Haikyuu. Yeah, so I'm playing right now. What are you playing? FF, right? Are you playing? What are you playing, Hazelnut? FF 14, right? Okay. I was gonna say I remember an expansion coming out for that. It's like, okay, it has to be FF14. I'm playing this game. I'm playing Atelier Ryza 2. That's what I'm playing. Because I played a bunch of Atelier games. So, I played Atelier Ryza 1. I've played 3 other Atelier games. I got hooked. Okay, this is like my 5th one of the franchise. And I still want to play more of it even afterwards. There's like 20 games in the franchise. It's crazy, but they're just super fun. Get me my inner weeb on. Gotta do it. But it's super fun to craft items and stuff and get your character better, and the stories are really good. So you know, really like that. This class is Shadow or Middle. Oh, that game is so tough, Athena. Oof. That game is actually really tough. Alright. No, that game is actually pretty hard, Shadow of War Middle Earth. You really, like, if you lose, you really get pushed back really hard in that game. 39 hours, that's still plenty of hours. You know, you put hundreds of hours into a certain game, you know. Athena said, get good. She ain't wrong. She ain't wrong. No denying, I gotta get good. JD, hello. Hello. This class is a match made never, that's good. Yusuf, you're doing good. Yeah, we're just about to get started with this second lesson here. We're about to get going here. All right. Okay. The Shay. You're playing Evil Within, or are you sure you playing Evil Within? It's a tough game as well. I like the challenges you take. It's actually really good. I'm a much more casual gamer. I'm not gonna lie. Are you any good at being imposter? I'm decent at being imposter. I won't say I'm great though. Imposter's pretty tough in that game. You really gotta outsmart your opponents, so. Alright, let's do this intro and let's get going here. I vent in front of you, that's right. I kill and vent in front of you, yes. You guys are talking about anime? Yes. We're talking about a little bit of anime. I watched a little anime this weekend. I was watching my so I'm a spider, so what? I was watching that this weekend. That is hilarious. Yeah, it's really cute. I have to say. I read a little bit of the manga before the anime, and so I'm like, I want to see how they adapt it. All right, JD, we don't talk about Gabby here. Don't make me time you out. We don't talk about Gabby here. I kid. All right. Yeah, so I'm a spider, so what is actually really fun. It's a really fun little isekai. Alright, we gotta do this intro here. We gotta get going, folks. Alright, let's do it. Okay, let's get started today. Welcome back. Welcome back to Monday. Hopefully, a nice weekend. So today we're gonna pick up where we left off last time. Last time we talked about how to find the standard deviation using our calculator. Alright. We talked about that. Talked about how to find this. Again, we used our calculator to go ahead and find that. We found the mean there as well last week. Using the calculator and not using the calculator, so we know some of the formulas associated with that as well. We also talked about the normal distribution. That was the last. Take care, Athena. You have a great one. Yeah, the documentary was a banger, Yusuf. That's true. So last week we also talked about the normal distribution, which was a unique distribution that had a very predictable patterns. It's completely symmetric. We talked about the percentages in each one here. Again, as well with +1 standard deviations, -1 standard deviations. Now today we're gonna pick up where we left off last time. Is that we want to talk about, say, generic distributions. So we're gonna finish off here section 3.2, and then we're gonna get to the last 3 sections here of chapter 3 as well, and we'll talk about a little bit more here at the end of class, certain things regarding the end of chapter 3. In any case, let's take a look here at question 11 here first and foremost. All right, so now question 11 says, what is Chebyshev's inequality? Yeah, when's our test? Our test, I'll talk about that more so close to the end of class there, Dave. So I will talk about the test there. It will get answered, I promise you that. That is a question I will reserve toward the end. But it will get answered, I promise you that. Because that has stuff to do with the end of chapter 3 there, Dave. So that's what the first test will be over, is up till the end of chapter 3. All right, so what is Chebyshev's inequality? So basically it says for any data set or distribution, at least 1 minus 1 over k squared times 100% of the observations lie within k standard deviations of the mean, where k is any number greater than 1. All right, now this particular inequality is made not for the normal distribution, because the normal distribution is a very unique type of distribution. This is for generic distributions. So like this is talking about like what we talked about last week, which was like saying skewed left or skewed right distributions fall underneath this particular category. Okay, so again, this is just a very generic case. Does the distribution necessarily going to follow this inequality? No, but it does give us a ballpark estimate about how many data items, in the data set are going to fall within a certain amount of standard deviations from the mean. So for example here, if we chose 2, we would just plug in 2 in for k, and then we get 1 minus 1 over 2 squared, which is 1 minus 1/4, or 0.75, which is representative of a percentage, and we'll multiply that by 100, which is 75%. Oh yeah, that would be helpful if I could show off notes. I'm a dumb. All right, give me a second. Let's do less dumb things. You guys, I thought I was showing you the notes, and I'm like, wait, why don't you guys see the notes? Oh, right, because I'm an idiot. Oh yeah, that's right. I forgot. I forgot. The brain fart of the day belongs to me. Yes, yes. There, I think that's a tad bit better. Here, I thought I was showing off the notes, and here I am being a dumb. All right, I'll give you guys a minute. No, I would never deprive you of the notes there, JD. Goodness no, I would feel terrible if I did. Oh gosh. I couldn't do that to you. I legit thought you were glitched. No, I'm not glitched. I'm just forgot. I'll give you guys a minute to catch up there. Sorry about that. Just let me know. Just let me know when you're done, guys, and then I can move forward. Man, it's cold, folks. Oof, it's only got colder. All right. Yeah. Let me see if I can put on my hoodie here. Just a second here. Once you guys are done with these notes, just go ahead and type in that you're done in the chat there. I'm just gonna go ahead and put on a hoodie here. right. Here we are. All right. Okay. Now that you're done there, all right, we'll go ahead and move forward here. All right. So we're not going to spend too much time here on Chebyshev's inequality outside of that, but generic distributions is where this is going to be applicable. Okay. Let's move on here to the next handout, though. That's going to be the most, that'll be the meat and potatoes here for today. All right. Okay. So up here is the next handout. Now, you don't have to write everything down here that you see here on the screen. I'm just going to preface it by saying that, okay? There are some things that are important to point out, okay? Again, you don't have to write down everything. There's just some things you have to point out here because we're going to use the calculator to go ahead and answer the next two questions, which are talking about how do we approximate the mean of group data here, and how do we find the standard deviation of that group data using a calculator. Now, a couple of the parts here I do want to point out here that we talked about last week is we want to say, okay, we talk about population mean and we talk about sample mean. Now, population mean here is listed as the letter mu. All right. Thanks for the follow again, Hazelnut. All right. So remember that the population mean here is the letter mu, all right? And remember that the sample mean is x bar, all right? Now, if we take a look at the population mean or the sample mean, they pretty much have the same formula here. You take the sum of the class of the midpoints times the frequency of the class and divide it by the sum of the frequencies. Okay, now the one thing that we have to, of course, be careful about is the midpoint of the class. That's going to be much more important here if we're trying to find, say, the approximate mean of some group data. So, if you take a look at this note down here, it says find the midpoint of each class before using the calculator. We'll take a look at that here in just a moment. How do we find the class midpoint here as a formula? Well, that's right down here. That'll be the lower class limit of class number 2 plus the lower class limit of class number 1, and we'll divide that by 2. We're going to take a look at how we can go ahead and solve that by hand, as for these cases here, we will need to find the midpoint here by hand before doing any calculator work. That has to happen. Okay. So how do we exactly go about doing that? Well, let's take a look at an example here because obviously, as you see there on the screen, that's a lot of words. And you're probably saying, it's really confusing. And I'm like, yeah, that is pretty confusing. I ain't gonna lie. So let's put it into a simpler format here. Let's go ahead and put an example. Let's actually put numbers to this and let's see how things work out. It's not as bad as it seems based on what you see there on the screen. So just don't get freaked out. So the example we're going to do here is an example we did a long time ago. Well, I should say a long time ago, but here at the beginning of the course. And that was when we arranged data in a frequency distribution. Now here's the difference. The difference is that in this particular instance, okay, the difference is in this particular instance, I'm going to give you a frequency distribution. All right, so I'm going to give you a frequency distribution right off the bat. So I'm not going to give you any data items. I'm just going to give you a frequency distribution. So let's take that set of test scores. Remember that set of test scores that we talked about from before? Like we said, okay, 50s, 60s, 70s, 80s, 90s. We're going to go ahead and use that same example here once again. So I'm going to set it up the same way. I'm going to say, okay, we have some scores in the 50s, so 50 to 59. We'll have, say, some scores in the 60s, so 60 to 69. Some scores in the 70s, 70 to 79. Some scores in the 80s, 80 to 89. And some scores in the 90s, 90 to 99. Okay. So let's make up a frequency chart. So let's make up a frequency distribution here. I'm just going to randomly make up some frequencies, okay? No rhyme or reason why I'm picking this. So let's pick 8, and then 11, and then 9, and then 15, and then 7. Okay. Okay, so let's say this is our This is our frequency distribution for this particular problem. Okay, there it is. All right. Now, what we first need to do here in this particular problem is find the midpoints. Now, let's follow the formula that we have here. The class midpoint, lower class limit of class 2, lower class limit of class 1, add those together and divide by 2. So, for us in this case here, make up a third one here. What's the subscript of I? Okay, so the subscript of I here is basically just representative of each class. That's what I represents. Fi, just Fi like the letter I. I can zoom in on that if you want. Sorry. Need to go to the left there. Again, you don't need to memorize this per se, Planet. So we're going to actually, again, in practicality, it looks super confusing with the letters. So I just want to put it in more practical purposes without the letters. So it's not like, again, crazy. We're not going to be doing this by hand anyway. We're going to use the calculator, of course, to find this stuff. So that's kind of important. All right, so let's find the midpoint here of each class. So the midpoint here, again, if we talk about class 1 and class 2, right? We have the lower class limit. Let me zoom out here. We have the lower class limit of class 2 plus the lower class limit of class 1. So again, these have to be 2 consecutive classes or categories. So this could be class 2 here, and this could be class 1. So if we're going to find the midpoint here of this class, we're going to take 60 plus 50, and we're just going to divide that by 2. So outright here, we're just going to get 55. Now you could probably guess what's going to happen here for the rest of these, but I'm just going to go ahead and write them out anyway. So the class 2, class 1, if we're just going to look at 2 consecutive categories / classes, whatever the case may be. We got 70 plus 60 here. We got 65. We got 80 plus 70. Here we get 75. We get 90 plus 80, which is 85. Again, just the next one up. Now you're probably saying, well, hold up a second here. What about 95? Well, for 95, all we have to do is imagine that there was another category after 90 to 99. So if there was another category, even though it doesn't exist, if there was another category here, it would be 100 would be that lower class limit. And then I just add that to 90 and divide it by 2. So by this. So here we get 95. Okay, so here are our midpoints here, 55, 65, 75, 85, and 95. Okay, you could probably, again, I fully expect you guys to probably see this pattern here. That's not too hard. But again, how we found each of those, again, very important here nonetheless. Okay, so let's go ahead and take out our calculator now. All right, so we're going to take out our calculator here, and we're going to figure out some stuff here to find our mean with our group data here, and we're going to find the standard deviation as well. Let's take out our calculadora, la calculadora, and let's go ahead and do it. Okay. All right. All right, so if you have your calculator in front of you, I want you to go ahead and hit the stat key here on your calculator. So I'm going to hit the stat key here. We're going to go over to edit. Now, if you have stuff already entered in, we're going to go ahead and clear out these lists. So to do that, highlight the list, hit clear, hit enter. I'm going to hit clear and hit enter. Okay. So there we go. We should have our list cleared out. Nice and easy. So in list number 1 here, what we want to put in list number 1 here specifically is we want to put our midpoints here in list number 1. Okay, so that's what should come first here. All the midpoints here should be in L1 or list 1. So I'm just going to go ahead and put here all the midpoints here in list number 1, just like so. Now, there is going to be a bit of a difference here this time. Last time we just put in the data items into one list and we called it done, once we applied the calculation to it. This time, though, we're going to need a second list. Okay, our second list should be our frequencies. Okay, so our frequencies here need to be our second list. So we have 8, we have 11, we have 9, we have 15, and we have 7. Okay, so I put my frequencies here in list number 2. Akari, thanks for the follow. Appreciate that. All right. So once you guys have that list, once you guys have that in your calculator, go ahead and type in yes in the chat once you have that done. Again, if you have any questions here or if you're stuck, just let me know now. So I want to be sure everybody's on the same page as I go through this example. Hopefully everybody's good. All right, I'm going to move forward now. Okay, so I'm going to just assume that everybody's got that stuff going. Okay. Yes, okay. Good, good, good. Okay, so what we're going to do next here is we're going to hit the second and mode key. We're going to quit to the main screen here once again, making sure we don't enter anything bad in those lists. All right, I'm going to hit the stat key here once again. All right, we're going to go over to calc. Okay, we're going to go over to calc. All right, this time. Now we're going to once again use the 1var stats. Okay, so we're still going to use 1var stats here just like we did from before. Okay, so that part there is not going to change. So let's go to 1var stats. Now, if we go to 1var stats here, we are going to see we're going to make a little bit of a change here. On the very top, you should see L1. L1 should be your list, okay? If you don't see L1 there, you can easily change that by hitting the second key and the number 1 key, and L1 should show up on that blank. The frequency list, though, we actually do have a frequency list here because we're taking a grouped set of data. So for the frequency list, we're going to hit second and 2 and the number 2 for L2, list number 2. Okay, so you have to have that frequency list in there. Now, if you have the old school calculator, if you just see 1var stats here on the screen, okay, let me take my face away for a second. All right, so if you just see 1var stats here on the screen, then what you need to put is you need to put L1, comma, L2. The comma key here can be found right above the 7 and right below the sign key. So L1, comma, L2 if you have the old school calculator. If not, then you could just go ahead and enter in exactly what you see here and go down to calculate, and the calculator will do it in your stead. And this is what you should see here on your screen. If you have the old school calculator, it should look like this before you hit the enter key. Okay, and then hit enter. So it just depends what software you have. Of course, if you have the old school, new school, it just depends. So I'm going to go ahead and enter on that. Then we'll see what we got here. So want to be sure that everybody's got this here. Go ahead and type in yes in the chat if you do have these results that you see here on the screen. Or if there are any questions, please let me know now. Yes, okay. Again, anytime during this process, just ask me questions if you do have questions on the calculator, but I'm hoping everybody reached the same result here. You missed the part after inputting L2? Okay. So Hazelnut, you'll need to hit second in mode. Okay. Hit the stat key here. Go over to calc. Go to 1var stats. Make sure that your list here is L1. Your frequency list here is L2 to get L2 to show up on the screen. Hit second and the number 2, and then hit calculate. And that should get you to that screen there, just like so. Let me know once you got it there, Hazelnut. All right, cool. Anybody else? Anything else? I'll move on if nobody has anything else. Okay. I'll just assume that and we'll move on. All right. So let's take a look at our results that we have here. Okay, so the results that we have here at the top, we have X bar here, which is our mean that we did look for. Okay, so our grouped mean here is going to be 75.4. Okay, so that's just how it turned out. That's fine. And again, here we have SX here. Again, we talked about this last week. SX was the sample standard deviation. That's 13.2419. Remember going out to 4 decimal places in this instance. And we have rho X here, which was population standard deviation. So 13.1089. 1088, sorry. Okay, so there we have our sample and population standard deviations as well. All right, now remember what this is used for. Why do we use group data here sometimes? Well, sometimes you may not have the exact data items in the data set. Notice I just gave you the frequencies here. So again, if you have 8 scores between 50 and 59, you don't know exactly what those scores are, okay? So that's why we take the midpoint here. We're kind of meeting stuff halfway. I don't know if we have 8 scores that are exactly 50. Maybe I have 8 scores that are 59. I have no clue. All right, I have no idea. So I need to meet myself halfway, and that's why we take the midpoints here in this instance. I mean, I could have 51, 52, 53, 54, all the way up to 58. For all I know. That's all, but I don't know that because they're just frequencies. So they can be any scores within any one of those ranges at the end of the day. So if we had something more concrete, we could make much more pinpoint accurate results, but this is what we got to work with. So in group data, this is generally how it works all the time. All right. Okay, any questions about those first 2 questions there? Any questions at all before we move forward? Okay, not indeed. All right. Okay, good. All right, so let's go ahead and take a look here at the next one. All right, so the next question here. Wish it wasn't so dry in here. All right. Okay. All right. So the next question here is something that is going to be important later on. So, yeah, you're right, Ashley. Hydrate. Me wrong. There we are. Okay. Okay, so What we're going to talk about next here is we're going to talk about z-score. Now, z-score here is one of those is very important here in terms of we're going to use z-score here as kind of like a middleman to basically get to something else where we can start going ahead and interpreting, say, particular data items in a data set. So if we want to actually make conclusions here, we want to go ahead and do that here via a z-score. Now, what is a z-score here specifically? Now, a z-score here specifically talks about the number of standard deviations a data item is away from the mean. All right, so we talked about, say, +1, +1, -1 standard deviation. So we said when we looked at the normal distribution example last week, we said, okay, +1 standard deviations would be like, okay, that's above the mean by +1 standard deviation. So in our example, I believe last week we had 10 as our mean, 2 as our standard deviation. We looked at the number 12. 12 is 10 plus 2, which is 12. Again, that's +1 standard deviation. Again, that's 1 standard deviation above the mean. We could also have minus standard deviations. Again, we took -1 standard deviation. We took 10 minus 2, which was 8. And so we got -1 standard deviations in that particular instance. Okay, so that we can also have as well. So that's just the note where I put up here. It says it's okay to get a negative z-score. That's perfectly fine. We're more than welcome to have a negative z-score as much as we're having a positive z-score. Okay, positive z-score represents above the mean. Negative z-scores represents below the mean. Okay, so that's what that represents. Now, the formula that goes with this is also very important to get to know, and that is that the z-score here is equal to the data item minus the mean, and that particular answer divided by the standard deviation. So we will need to know some information prior to finding the z-score. We'll need to know what the standard deviation and the mean of a particular data set is going to be. But once we have that, we can find the z-score here of any other data item that we want to test over at the end of the day with that particular data set. Now, this also has some implications. This implication means that every data item has a unique z-score. Okay, so because we can test every single data item there and we'll get a different number there every single time. The only time that you're going to get the same z-score here is if they're the same exact data item. Okay, so at no time will you get the same answer for two different data items. That will never happen. You'll get a unique answer for every single one because of how the formula is set up, where we have to physically actually take the data item and subtract it by the mean. So it's always going to be different every time down. As for the notation here for a z-score, in the book, you're going to see two major notations here for z-score. You may see the letter z, or you may see z with the subscript of the data item. So for example here, you may see this. You may see z sub 58. Okay, and then this would be a notation there for a z-score. Okay, again, that's specific to just 58 and that particular z-score associated with it. So the book kind of likes to change things up. If there's any other notations regarding that, of course, I'm going to let you know. There will be one instance where I'm pretty aware that there will be, but we haven't, excuse me, we haven't gotten to that point yet, so it will be a while yet. Okay. Are there any questions so far? We're going to do an example here, of course. Hopefully that's pretty easy. Let's do an example, though. Let's do an example of a z-score here. So we have let's make up a couple of things here, I guess. Make up a mean. Let's see, what should the mean be here? The mean here is going to be let's call it 23. And let's have the standard deviation here be, let's call it 3. Okay, so we have a mean of 23. We have a standard deviation here of 3. Let's go ahead and find out what the z-score of some particular data items are going to be. Easy enough. So let's take a z-score here of 25. Okay. We'll take the z-score here of 25, and we're going to go ahead and see how that's going to work out. So I'm going to plug in 25 here. I'll put 25 here in parentheses, so that way you know that the only thing that really changes is the data item. The mean and the standard deviation are given to you here. So we're going to subtract that by 23. And we're going to divide that by 3. So here we get 2/3. In this particular instance here, we're going to go to 2 decimal places, which will be a little bit more apparent later on here. So, if we do this out here, we're going to get 0.67 here as our z-score of 25. All right. Okay. Let's do another z-score here. Let's do a z-score of 15. Can you guys tell me what the z-score of 15 is going to be? Let me put up the camera here. So can anybody tell me here, what is the z-score here of 15? Z-score of 15 is 9. I will get a decimal here. Oh, okay. Oops, 50. Woo. Well, yeah, 50 would be 9. That's true. I was going to say, I'm like, whoa. Minus 2.67. Okay. Good. So that's correct. We got minus 8 divided by 3 here. So minus 2.67 is correct. All right, no problem about that. Very nice. Okay, good. So that's what we got here for z sub 15, or the z-score there associated with 15. Okay, now what are we going to do with these z-scores? Why are these so important? You know, what's the point of z-scores here? Well, what we want to link z-scores to specifically is the next question here, which is question 4. What does percentile mean? Okay, so percentile is going to mean a pretty important big deal here. So I'm going to go ahead and at least make this a little bit understandable. So to make this understandable, I'm going to start a poll here. Let's that wasn't that wasn't the poll I wanted. All right, let's go. All right. All right, so I'm going to start a quick poll here. So, have you taken the SAT, the ACT, SAT, or both? Go ahead and vote at the very top there if you've taken the ACT, SAT, or both. So vote at the top there. Yeah. Oh, something went wrong for you? Oh, whoops. Okay. Let's try it again. That's okay. I'll just make up another poll. Right. All right, let's try that again. I want to see the breakdown actually. I'm actually kind of curious, so I'll extend it for a little bit more time here. We'll see if it works there. There we go. Now it's working. All right. It's always interesting, the breakdown. So I'm actually really curious if you took the ACT, SAT, or both. Still got the poll up there. If you'd like to take the poll, did you take the ACT, SAT, or both? ACT, SAT, or both? So I see a couple people there taking the ACT. I see 6 people there taking the SAT. And looks like one person has done both. This is actually a fairly interesting split. I ain't gonna lie. I've gotten really unusual splits in all 3 of my classes that I've asked this question to. It actually is really interesting to see the testing backgrounds of everybody here in the chat. So a lot of people from the first class actually said both, which was actually really interesting. So I like, I mean, there's a lot of interesting patterns you could certainly get from that. I took the ACT personally, so that's what I did anyway. All right, so SAT 6, ACT 2, and both being 1. Now, if you took the SAT there, let's at least get that down. The SAT is out of 2,400 points. The ACT is out of 36 points. The SAT used to be out of 1,600 points, and they revised that to 2,400, I believe. And again, if you took both, that's really, really good too. Again, probably, a lot of people take both to try and get into schools on both coasts. So, which is completely understandable. If you want to take courses, if you want to go to a school on either coast, then taking both is probably the best idea. But let's think of it this way here. SAT was required at your high school, but your college press will allow us to take the ACT for free outside of school. Yeah, for me, I took the ACT because for U of I, you had to take the ACT to get admitted. So I was like, okay, I want to go to U of I. So they're like ACT, and the SAT wasn't even considered. Most of the time, at least from when I took the test way back in the day, ACT was more considered for East Coast, and SAT was more considered for West Coast. Now, I'm pretty sure that that's not the same as it was once before, but that's how it was back in the 90s. So I know it's really, really different now than it used to be. So it's definitely different. You didn't know ACT existed until college. That's fair. That's fair, Planet. Yeah, it it really depends which school. Back in my day. Yes, yes. I did take the ACT. I did take it twice. You know what? Here, let's do this. Okay, let's do this. Let's talk about this here. Let's have you guys do a prediction. Let's guys have you do a prediction here. You can bet your channel points. Your channel points here. Now channel points aren't real aren't, you can do anything you want with the channel points there. Let's start the prediction here. What did I get on my second ACT attempt? So for ACTs you can attempt that. I took 2 of them. What did I get on the second ACT attempt? All right, so make your predictions now. Did I get above a 25 or did I get 25 or lower? Did I get 25 or lower or above 25? So you can bet as many channel points as you want here. Again, you got 25 seconds there. All right. Ooh, somebody bet 2.8K. Holy smokes. That's a lot of channel points. 2.8K. Woof. Woof. Holy smokes. All right, let's take a look here. Somebody put 2.8K on that. Jeez. Jeez. All right. I gotta predict this. Okay, so my score on the second one was indeed 25 or lower. That is correct. 25 or lower is correct. So I actually scored exactly a 25 on the ACT there. So congratulations, Ashley, and what you say? You guys bet a ton of points. 3K on that. Woof. Woofo. Woofos. Woofos. Wow. You guys are mad. That's mad. That's pretty awesome, though. You guys are amazing. All right. Yeah, I actually scored a 22 my first time. You remember, you said I wasn't a good student. No, I was not. I was a B student in high school. I was a B student in high school. So always the B's. The B's for me. I got some A's and I was like, okay, but mostly B's. I had like a 3.25 GPA. It wasn't the greatest in the whole wide world. It wasn't like overachieving, it wasn't underachieving. It was just kind of there. Which is fine. That's perfectly fine. You can get by with a lower-ish GPA without having to feel too much pressure. So so yeah, I got a 22 the first time I went to a prep school, and then I got a 25 the second time on the ACT, and that was it. So I remember the ACT being really tough when I took it, but you know, I look at it now, it's not, oh, that's not as bad as it may seem, but it requires some effort to do, that's for sure. Still requires effort. Now, it was now I don't know if you guys got this, but if you guys did the SAT ACT, you got your scores back in the mail or an email or whatever. And what they did was, don't forget what they do. They do is they basically compare you to how everybody else did in that same test. Okay, so for example here, if I scored a 32 in the math portion of the ACT, then basically they would compare you to everybody else who took the math portion of the ACT, and they would say, oh, your score of 32 is in the 93rd percentile, 93rd percentile, which means that, just as an example, so basically that means that you did better than 93% of the people who took that same exact test in that same exact math section. Okay, so what we want to actually link in this case, and why I mentioned ACTs and SATs from back in the day, is those grade reports that you got. Those actually do kind of factor into what we talk about when we talk about percentile. We talk about percentile. When we talk about it from a statistical point of view, we want to think about it in that same way. All right? So we want to say the data item is, if we want to talk about what does percentile mean, it means that the data item is K% better than all other data items in the data set. Okay, so meaning to say you scored a 30 in the ACT, that means that you did better than 93% of the people who took that same exam for that subject. Okay, or again, it can be viewed the other way, is that 93% of people did not do as well as you did. It's lower. So if we're talking about a generic data item, then it was saying there 93% of data items in the data set are lower than that data item, or that for that data item, for that particular data item is 93% above all the other data items in the data set. Okay, so that's what percentile means, and what we want to be what we were going to be looking at here later on in this semester is we're going to link this z-score here to a percentile. Okay, we're going to link the z-score here to a percentile. In the back of the book, they actually do talk about percentiles and z-scores, and we're going to see exactly where that kind of fits in if we're trying to make some conclusions based off some studies that have been done. All right, so that's going to be pretty important there in that particular case. All right. Okay. Now, there are unique percentiles here, which we are going to call quartiles. Oh, but before we do that, we're going to get to that here in just a second. Are there any questions that you guys have? Any questions? Any questions at all? Want to be sure that at least we're doing good here so far. No? Okay. So let's go ahead and move on here. Now, what we're going to be doing next here in relation to these percentiles is we're going to take a look at the end of chapter 3 here right away, which is talking about box plots. Now, box plots is another way to organize and arrange data to take a look at the type of distribution, or again, taking a look at an overall big picture perspective of the data set in general. Now, to kind of highlight that here, let me go ahead and talk about that here for just a second. If you take a look at the end of the handout here, the last question here talks about how do we construct a box plot. Now, we're going to get through a couple of these steps here today. We won't get through this entirety of this today, but we are going to get through a couple of these parts here today, so at least you can see exactly how to start on that, and then we're going to move forward from there. So what we're going to need to have here, of course, is let's go ahead and make up a data set here. And yeah, we'll make up a data set here, and then from that, we'll go ahead and start with that. So I'm going to be, just to let you know here, I'm going to be kind of moving back and forth here just a little bit from this last question, your question 9, to the other questions here. So don't be surprised if I'm just kind of moving back and forth here. I'm going to be doing that a little bit often here. So, because these refer to a lot of the different questions that we have from before, but I kind of want to do them concurrently as we're going through about how we can construct a box plot from scratch. So that's kind of the point I'm trying to make here in this instance. Okay. So for our example here specifically, let's go ahead and put up a stem and leaf plot once again. We're going to have stem, and we're going to have a bunch of leaves. Now in this instance, let's go ahead and I'm just going to make up numbers here. There's no rhyme, no reason. I don't really have a reason why I'm picking up these numbers here. Let's see, 4, 0, 1, 1. Okay, so like I said, I just made up these numbers here on the fly. There's no rhyme or reason what these numbers mean. Okay, but this is our data set here in a stem and leaf plot form. Okay, so let's go ahead and talk about here what we're going to be doing first. As you can see here on the screen, let's start off with the very first part here. Step number 1. Step 1 says order the data set and find the median. Now, I went ahead and already ordered the data set, so we are pretty set and ready to go there. More importantly, though, is what from this stem and leaf plot here, let's talk about the median here. Okay, we need to find the median of this data set. Now, what we have to do is when we find the median here, we have to find, first of all, the position of the median. So remember the position of the median here. So can anybody tell me here, what was the formula for the position of the median? Right? What was the formula here for the position of the median? Because before we find the median here, we have to find the position of the median. Can anybody tell me here, what was that formula there for the position of the median? Again, you could type this out here on chat. I know this is possible. So, what was the position? What was the formula there for the position of the median? Okay. Okay, very good. That's correct. N plus 1 divided by 2. That's right. Very good. So we have n plus 1 divided by 2. Now, what's n here in this case? How many data items in the data set do we have? What would n be here in this case? A 21. That is correct, Alyssa. Very good. That's right. There are 21 numbers here in the data set. Okay. So we have 3 plus 4 is 7, plus 3 is 10, plus 4 is 14, plus 5 is 19, plus 2 is 21. So there are 21 numbers in the data set. So what we're going to do is we're finding the position here first. We're going to have 21 plus 1 divided by 2. That's 22 divided by 2. So we're going to be the 11th position. Remember, 11 is not the median. It is where the median is located, is in the 11th position. So let's count up to 11 numbers here. And let's go and see what our median is going to be. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 here is our median, which is going to be 32. Now, to make things here a little bit more clear, I'm going to go ahead and put an arrow here right above 2. And I'm going to circle that in black. All right, because that's where the median would be located here in this instance. Okay. Before we move forward here, are there any questions about that? Any questions on how we found median there? Nope. All right. Okay. I'm going to move forward here. Okay. So the next one here is going to be, again, how do we order the data set and find the median here? So we found the median here. Now, the next two parts here is we have to find Q1 and Q3. Okay, so let's find Q1 and Q3 here in this particular instance. All right. So in order for us to understand Q1 and Q3, we're going to have to understand what quartiles are. Now, Q1 here is the 25th percentile. Okay. Q1 is the 25th percentile, and we do have a very specific meaning about what it means to be the 25th percentile. Let's take a look at what that meaning is. So the 25th percentile says that the median of the data set is going to be the median of the data set that is to the left of the median. Now, you're probably wondering, what does that mean in terms of median of the data set that's to the left of the median? Take a look at the picture that we have here off to the right with our data set in there. Notice our arrow here I pointed to the specific number that is our median here of our data set. So I'm going to pick the entirety of all the numbers that are to the left of our median here that I circled, which was 32. I'm going to circle that here in purple. This is the data set that is to the left of 32. Okay, just like so. I'm just going to circle it just like so. And what I want to do here is I want to find the median of those numbers specifically. And then that way, I'm going to be able to find Q1. All right, so let's not forget here. I circled all the numbers here to the left of the median, and now I want to find the median of those numbers to find Q1. So first and foremost here, if I'm going to find Q1, I need to find the position of the median here in this instance. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 numbers here circled with this purple circle here. So the position of the median, I'll put this in purple, position of the median is equal to 10 plus 1 divided by 2, which is going to be 5.5. So now all I have to do is find the 5.5 position here. So 1, 2, 3, 4, 5, 6. So the 5.5 position here is going to be right here between the numbers of 11 and 18. So I'm just going to do this the same way. I'll make this a bit bigger here so we can follow along. So we're going to have Q1 here, which equals 11 plus 18 divided by 2. So our final answer here for Q1 will equal 14.5. Okay, so Q1 here is going to be 14.5. Are there any questions about that? I want to be sure that you guys can clearly see where I got 14.5 here. Well, that's very easy. All right. Good stuff, good stuff, good stuff. All right. All right, if everybody's good here, let's go ahead and go to the next part here. So the next part here is going to be specifically for Q3. So let's go there. That's not it. All right. So let's go down the list here. Actually, let's do that first. Let's go down the list. So down the list here we have Q2, which is the 50th percentile, which is the median here. Okay, so the 50th percentile is the median. We don't call it Q2, we just call it the median here because that's normally what we're pretty used to by this point. Okay, so that shouldn't be too hard to figure out. It is what it is, and you're like, yeah, it is what it is. Quickly do this. Okay, so Q3 here is the 75th percentile. Okay, so Q3 here is the 75th percentile. So basically that's going to be the median. It is what it is. This is true. Yeah, but it is what it is. All right. Q3 here is the 75th percentile. It is the median of the data set that is to the right of the median here. Okay, so the median of the data set that is to the right of the median. So what does that mean? Well, let's circle all the numbers that are to the right of the median. So I circled the median here. Okay, 2. I want to circle all the numbers that are to the right of 2 here. Also, notice here is that I am not including the median as part of the data set, by the way. That is never included. So everything to the right, but I'm not including the median. Okay, now I'm going to find the median here in this data set that I've circled here in red. All right, so for us to do that here, in this instance, I'm going to find the 5.5 position. I can't even say that out of my mouth. So let's count it out. 1, 2, 3, 4, 5, 6. So actually, here we go. Is between both of these guys. So we're going to find the mean here in this case, and that's going to be what Q3 is going to be equal to. So as you can clearly tell, it'd be 41 plus 41 divided by 2. So since they're the same number here, we're just going to get 41 right back. So we have Q1 here. So let's at least take stock of what we have here. We have the median here, which is 32. We have Q1 here, which is 14 and a half. And we have Q3 here, which is equal to 41. Okay. So that's what we have going on there. All right. Finally, let's take a look at the last part here of. Oh, there you go. Okay. Finally, let's look at Q4 here. Okay, so Q4 here is the 100th percentile. Now, technically, we don't call it Q4 because all we have to do here specifically is we just look at the highest data value in the data set. Okay, so the highest data value in the data set here, according to our chart, according to our data set here, is 59. So 59 here would be Q4 or the 100th percentile. We don't obviously state it. We're going to just basically state, oh, it's 59, the highest value there. All right, but you don't really call it Q4. We already know it's the highest value because we already ordered the data set ahead of time. And we just look at the last number there as part of our quartile. So that's how we can get Q1 to Q4 here of our percentiles here. Now, as you could probably already tell, we're going to be doing a few other things with these particular data items, with these particular pieces of information, excuse me, such as Q1 and Q3 here. All right. In order to get to our box plot that we will be looking for here at the end of the day. So remember, we are going to be constructing a box plot here with this particular data set, but yeah, we're going to be reserving that here for next time. So this is where I left off here for the first class. So this is where I'm going to leave off here for you guys as well, because I want to keep you guys at the same pace here, so no one's moving ahead or behind. Now, one thing I do want to talk about though before we yeah, but there is something important we do need to talk about here, JD. So let's talk about that here very quickly. Is the test. Now that was mentioned earlier here. Dave asked a question like, hey, when's the test? When's that going to be? Okay, so once we're done talking about box plots here, which will probably be on Wednesday, we'll be discussing here more about the exam for next week. More than likely, next week is when the exam will be due. So more than yeah, I can go back to the steps there, Planet. Sure. So more than likely here is that the test will probably be due next week. I haven't made up the test yet, so that's something that I'll have to do tomorrow. But I'll be making up the test there, and then when I make up the test, we'll be talking about specific details regarding the test there. Of course, I plan to keep it rather short. I'm trying to keep it short, like 20 questions or so, something reasonable. There's a couple things I can tell you right away about the test. There will be a practice test that you can certainly take as many times as you want. That practice test will have exactly the same type of questions that you'll see on the test there. You can try those as many times as you want to get comfortable with the formatting, and get comfortable with the types of questions. They should be questions that you've seen on the homework, so they shouldn't be anything whole brand new. Yes, the tests are timed, Julia, but let me go ahead and describe some of that here regarding time. I'm going to give you a ton of time, and I do mean a ton of time. One of my hallmarks that everybody talks about is how much time I give on tests, and I usually tends to be a ton. All right, so I do mean a lot. So if it means like 8 hours on the test, I give you 8 hours on the test, literally. I'm not. It won't shock me that I'll just decide on 8 hours, and then there you go. There's also be a save for later option, which I'll talk about on Wednesday, which will allow you to stop the test and then come back on another day, and then restart the test where you left off. The only caveat is that you're not allowed to redo questions that you tried from before. So that's the only caveat about a save for later. Open note, yeah, that's fine, obviously. not really going to be able to do a whole lot from here. But yeah, I mean, it'll be an accurate kind of reflection there for the test. Again, we're here to learn stuff, so it's not. I don't want to make the test like a really super stressful experience. All right, so want to be able to work with it as best as possible, without having to feel overwhelmed. So those are some things I can talk about right now. Enrique, thank you. No problem. Those are some things I can talk about right now because those are the things that are certainly set in stone. Because I already know like the rules and stuff kinda already. Um, More than likely it'll be due like on Sunday, like at the end of the day on Sunday next week. So I'll give you like a week and a half to finish that first exam, and then there you go. So that should be honestly plenty of time of which to finish, the first exam. If it's not plenty of time, I don't know what to tell you, in all honesty. But it will be over the first 3 chapters here. So once we do finish chapter 3 here for next time, um, we'll get to chapter 3. We'll also get into a little bit of chapter 5 here, which is the next chapter up. But yeah, that's kind of like the goal here. Get chapter 3 done, and then start on chapter 5 there, and then we'll go from there. Yeah. You're amazing. Thanks. I appreciate that. I figured that's the fairest possible format. If you guys got complaints, I don't know what else to tell you. Yeah. Usually I don't get a lot of complaints about the testing format, but yeah. Homework is due the last day of the test. Yeah. So if I say the test is due on Sunday, then that means that the homework will be due on Sunday as well. Yes. And I will have to make changes to the due dates for the homework. I just need to like I said, it's just more along the lines of when that happens based on the pacing of the course. So once that happens, then that's what we kind of go with. The test will be next week. It'll probably be due next week on Sunday there, Megan. So on Wednesday, I'll discuss about that more in detail. I promise you that. So I'll be making up the test here tomorrow. And then you'll get to find out all the details, including how many questions there are and more specific details, of course, about when I make it due and all that jazz. So I can only fill you in on certain details now because I don't know what I'm going to be doing here until then. So, but yeah, you'll know more for next class. I promise you that, Megan. All right. Okay. Good question there. So the homework there, the homework that you should be done, homework up to section 3.5. Okay, so homework will be up to section 3.5 that'll be due for the test. So once we finish up chapter 3 here on Wednesday, that'll be all the way up to 3.5. If you like to work up to what we've covered here today, that'll be up to the beginning part of section 3.5. Okay, we'll finish up the latter half of section 3.5 here, 3.4, 3.5 for next time. Okay, so we're gonna get through all that stuff there for next time. That'll get you all prepped and ready to go. All right, so that'll get you far. That's for sure. All right, so that'll be due for the test there. There's a lot of time between here and next Sunday, obviously. But yeah, that's the goal here for right now. I'm not going to make changes to the due date until I actually have made the test. So I just like to go in order like that. So you may see a change in the due date there tomorrow, but not until I make up the test. So you guys have any other questions? Any other questions, guys? You guys can ask me anything else. All right. The handouts count as homework? No, JD. The only homework that counts are the ones on my math lab. The handouts are just optional problems if you want to do them or not. All right. Well, I want to thank everybody here for coming out here to the stream. Yep, that's it. I promise you. All right, everybody. I want to thank you, everybody, for coming out here to the stream once again. Thank you so very much. All right. I really appreciate it. You all are very wonderful. I love you all. We are going to see you back in a couple of days on Wednesday, okay? We're going to talk about more Chapter 3. We'll get in a little bit of Chapter 5, and we're going to go ahead and talk about the test then. All right? Have a great one, everybody. We will see you later. Take care of yourselves, everybody. Stay safe, stay healthy, and most importantly, stay sane. All right? Have a great one, everyone.
There's not a single day that passes without you on